Hello and welcome to number 6. We're going to be solving some equations with square roots in them. Now this one is a linear equation. We know that because the degree on x is 1. And that means that we can't get any more than one solution. Let me begin by talking about some bad ways to do this problem. So a bad approach to this problem would be this. Okay. We add roots of 8 to both sides. And then here, we're very tempted to say roots of 18 plus roots of 8. Could that be equal to the square root of 26? Well, let's see. Do I have my calculator around here? I do. Let's see what my calculator says about that. First, square root of 26 is a little more than 5. Square root of 18 plus the square root of 8 is a different number. So this is not true. So the best that we could do is we could say roots of 2 times x is equal to roots of 18 plus roots of 8. Then we could take both sides and we could divide by roots of 2. So we could say our answer is this. But that looks absolutely terrible. And there's a much, much, much cleaner answer to this. In fact, let me show you on Desmos. Let's go right here. Do they have a square root? Yeah, so let's go square root of 2 times x minus square root of 8. And then I want to set that equal to y equals square root of 18. And you'll notice that they cross right here at 5. So the answer that we just got right here has to be 5. And in fact, if I put it into my calculator, check it out. Square root of 18 plus square root of 8 divided by square root of 2 is 5. So how do we make that happen? Well, it's all about simplifying your radicals. So roots of 18 is roots of 9 times roots of 2, which means that it is really 3 roots of 2. Roots of 8 is roots of 4 times roots of 2, which means that it is really 2 roots of 2. So what we had right here, we could rewrite as, I'm going to replace the roots of 18 with a 3 roots of 2. And I'm going to replace the roots of 8 with a 2 roots of 2. Now, if you look at the numerator, we have 3 roots of 2, and then we have 2 roots of 2. So how many roots of 2 do we have total? We have 5 of them. You can combine these just the same way that if you had 3x plus 2x, you could call them 5x. We can call this 5 roots of 2. And now, since that's divided by roots of 2, these cancel or they're equal to 1. So our answer ends up being just the 5. The moral of the story, ladies and gentlemen, is you always want to simplify your radicals. On the next one, I'm going to actually make that my first step, and I hope you will from now on too. I'm going to start by saying this is roots of 2x minus this is 2 roots of 2x equals 3 roots of 2. Now, on this side, I have 1 root of 2, x, minus 2 roots of 2. So if I have one of these and I take away 2 of them, that gives us negative 1 roots of 2 times x is equal to 3 roots of 2. Divide both sides by negative 1 times roots of 2. We get x on this side. On the other side, the roots of 2 cancel, and we're left with a negative 3. Last problem for today. Same thing. I'm going to start by changing all of my radicals to their simplified form. And then the next thing I'm going to do is what we've been practicing all day, which is move everything to one side, meaning we're going to subtract 3 roots of 2x. So these cancel. We're left with 0 on this side. On the other side, we have roots of 2 times x squared minus, there's 2 of them and then 3 more, so we have 5 roots of 2 x's. Now I'm going to factor out the common factors. You look at this term and this term. They both have a roots of 2 we can pull out. They both have an x we can pull out. What are we left with? Well, this times, we need one more power of x, so that this times this will give us this, minus, for the second term, the roots of 2 and the x are accounted for. We just need the 5. So set this equal to 0. If roots of 2 times x is equal to 0, then x is going to have to be 0. If x minus 5 is 0, then x is 5. There's our solutions, and ta-da! We are done. Nice work today.